Hi dear students, welcome to plus one online classes. I am Abdulsalam, faculty of physics. You know physics is important for you, which is your core subject. So you must study very well from beginning. I think you studied first two chapters very well. Okay. Now I will show you what are the main content in your plus one physics, main chapters. You want to study 15 chapters from plus one physics. How many? 15 chapters. But the first chapter, physical world, is not important. The main content is included in the second chapter and fifth chapter. So it is not taken. You studied the first chapter as unit and measurement. I think you studied very well. Isn't it okay? Yes, it is very important. Unit and measurement we use throughout the physics from plus 1, plus 2 and in higher studies. So you must understand the things in units and measurement. Second, or the third chapter, motion in a straight line, it also you studied. It's very important chapter, very important, a fundamental chapter, because it's the basic of mechanics. In first year you study mainly mechanics. What is mechanics? Yes, mechanics is a branch of physics which deals with the states of motion, states of objects, motion, rest, etc. You know physics has a number of branches like optics. Optics deals with the light, you know, and thermodynamics related to temperature, heat, and nuclear physics, modern physics, electromagnetism, very important topic. Electromagnetism you will study in the next year. Okay, and here we study the mainly mechanics. The main portions are included in mechanics. What do you mean by mechanics? Okay, you got the idea from straight line. Basic idea you got from straight line mechanics. The next chapter is motion in a plane. We will discuss today this chapter, motion in a plane. Very important chapter and very important, but it is now new for you. Later it becomes very easy. Now the fifth chapter, laws of motion, you already know laws of motion, Newton's laws of motion, you are familiar. So it is very easy chapter. And work, energy, power, the next chapter also you know work, what is work, energy, what is power, etc. This will also be studied detail in this year. And the next chapter, rotational motion, it is new for you, new idea. Rotational motion. And eighth chapter, gravitation also you are familiar. Newton's laws of gravitation, universal law of gravitation you already studied, and related things something detailed. And the mechanical properties of solids, mechanical properties of fluids, mechanical properties of solids and fluids, a unit. And then thermal properties of matter, thermodynamics, kinetic theory from thermodynamics portion. And last two chapters also very important, oscillations and waves. These are the 15 chapters you want to study in the first year. Okay. Today we will discuss the fourth chapter from the NCERT, motion in a plane. You know, one-dimensional motion, two-dimensional motion, three-dimensional motion. You already got the idea from straight line. Okay, what is one dimension? Only one coordinate will change, x coordinate will change. The type of motion is straight line, because only x coordinate change, moves in a straight line. It is a one-dimensional motion. You got a few examples in real life in one dimension. But most of the motions are 2 or 3 dimension. Then why you study one dimension first? It is simple. That is why choose one dimension. But the common motion is 2 and 3 dimension. Okay. Now we understand that common motions are all related to plane or space. Two dimension means two coordinate will change, x coordinate and y coordinate. The motion is in a plane. This is called motion in a plane. If 3 coordinate change, it is called 3D, and it is in a space called motion in a space. We will study motion in a plane in detail. We can split this chapter into 3 parts. For simplicity, we can split the main topics into 3. First topic is vectors, second topic is projectile motion, and third topic circular motion. We will discuss detail these 3 topics. Okay, first topic vectors. It is actually a mathematics, it's not physics. Then why we study mathematics in physics? You know, mathematics is the tool for physics. It's the language of physics. If you want to study physics, you must study the mathematics. You will study vectors in second year mathematics, but we will go, I will give you the basic idea of vectors here. Okay. Vectors. Then projectile motion is one of the important 2-dimensional motion. Projectile motion. A boy throw a javelin, it is in a projectile motion, like that. Circular motion is also very common motion. Okay, circular motion. We will study circular motion also very detailed in this chapter. That is okay. This chapter we are dealing with the vectors. You already studied a lot of physical quantities. Can you say some examples? Yes. Yes, mass, length, time, speed, velocity, displacement, acceleration, force, work, temperature, etc. A lot of physical quantities are you studied. We can divide these physical quantities into 2. One is called scalar and the second one is called vectors. That means scalar quantities and vector quantities. Scalar quantities are physical quantities which has only magnitude, Such a type of physical quantities are called scalar quantities. Vector quantities in the vector quantities are physical quantities which have both magnitude and direction. I will explain what is scalar quantity and what is vector quantity. Just define. Scalar quantities are physical quantities which have only magnitude, no direction. Vector quantities are physical quantities which have both magnitude and direction. Okay, both. That is the difference. First we discuss a lot of physical quantities. Some of them are scalars, some of them are vectors. If they have direction, they are vectors. If they have no specified direction, they are scalars. For example, you want to buy some sugar, for example 5 kilogram sugar. You want 5 kilogram sugar. This 5 kilogram represent the content of the sugar, the magnitude of the sugar. It is completely specified by a number and a unit. It has no direction. Okay, then this 5 kilogram is a scalar quantity. That means mass is a scalar quantity. Another examples. Distance, you studied in the last chapter. Distance, it has no direction, so it is a scalar quantity. Speed, you already studied speed. It has no direction. It also a scalar quantity. A number of scalar quantities are there. Temperature, density, volume, length, work, energy, power. Like a lot of physical quantities are there which has only magnitude. They are scalar quantities. Then vector quantities, both magnitude and direction. You studied distance scalar and displacement vector. Why? Displacement has direction. Displacement. Suppose you have 5 meter displacement. It is not completely specified. If we say 5 meter displacement towards north or towards right or downward or forward, like that, then it is a displacement. It has direction. If this 5 meter represents the magnitude, like 5 kilogram, and the north or left, right, downward, upward, south, east, northeast, etc. represent the direction. So it is a vector quantity. Displacement is a vector quantity. Another example, velocity. Velocity has direction. Velocity may be positive or negative. You already studied in the last chapter. So velocity is a vector quantity. Another example, acceleration. Acceleration is a vector quantity. Another example, force, an important vector quantity. Force is a vector quantity. Another example, impulse. You study in the next chapter. Impulse is a vector quantity. Discuss in the next chapter. Momentum is a vector quantity. Momentum, linear momentum, angular momentum, you will study in the coming chapters. They are all vector quantities. Another example, torque, an important vector quantity. Torque, rotational force is called torque. It is also vector quantity. Just remind these names. Is it scalar or vector? That's enough. Okay. This is about vectors. What is the need for vectors? Why we use vectors? Vectors represent a direction. Direction is related with the motion. In one dimension, you studied straight line motion. In straight line motion, how many directions are possible? How many? For example, you are walking through a straight road. Suppose you are standing here. How many directions are possible? One forward and another one backward. 2 directions are possible. We can take any position as the origin, and right or forward taken as positive, left or backward taken as negative. Only 2 directions are possible in one dimension. For another example of vertical motion, we drop a stone. It's moving downward. Okay, downward or upward. Only 2 directions are possible in one dimension. But in the case of a 2 dimension or 3 dimension, we denote 1D, 2D, 3D. 1D means 1 dimension, 2D, 2 dimension, 3D, 3 dimension. But what is the meaning of 1 dimension? Only one coordinate will change. You know, coordinate is the reference. We will represent the position with a reference. We use the reference as the coordinate system called Cartesian coordinate system, a simple coordinate system called Cartesian coordinate system. And you studied x-axis, y-axis, z-axis, etc. And the 3 axes meet at a point that is called origin. It is taken as the reference. With respect to this reference, only one coordinate, x coordinate, will change. It is called one-dimensional motion. The type of motion is straight line. If 2 coordinate will change, x and y will change, then such type of motion is called 2 dimension, 2 coordinate, 2 dimension. The type of motion is in a plane. You are walking through the floor. It is 2 dimension motion. X and y coordinate will change, but height will not change. If height also change, then x coordinate will also change. That is 3 coordinates, x, y and z coordinates are changes. Then it is called 3 dimension motion. In 3 dimension, a lot of directions are possible. Also in 2D, you are playing in a ground. How many directions are possible? How many directions? A lot of directions are possible, not two. A lot of directions are possible. In one dimension, only two directions are possible. One is taken positive, another negative. It is okay. But in 2 dimension and 3 dimension, a lot of directions are possible. To describe the 2 dimension or 3 dimension, it is very important to study about or use about vectors. We will use the vectors for 2 dimension and 3 dimension. Okay, we will study only 2 dimension. It can also apply 3 dimension. Okay. Next, representation of a vector. Vector have both magnitude and direction. If it is a scalar, we can represent a numerical value and a unit. You already studied 5 kilogram sugar, only magnitude. But to represent a vector, it has both magnitude and direction. We represent magnitude and direction. We should represent both magnitude and direction. A vector is represented by, very simple. We will use this representation in throughout the chapter. So listen carefully, it is very important. We will represent the vector with a straight line, with a straight line. Straight line. And another important thing, with the arrowhead. With the arrowhead. This represents a vector. A vector graphically represented by a straight line with an arrowhead. For example, this is a vector OP. Vector OP. This vector OP has a straight line. This straight line has one origin and one head, arrowhead. This origin is called the tail of the vector. Origin is called a tail of the vector, and the arrowhead is called a tip of the vector or head of the vector. A vector has 2 parts, the origin called the tail and arrowhead called the tip or head of the vector. Now, what is the magnitude and direction in this graphical vector? Okay. This length represent magnitude. The length of the vector represent magnitude. For example, another vector, we draw another vector. Is same OP? No, it's another vector. It has small length compared to OP. It is smaller. It's another vector. Its magnitude is less. Okay. Then which represent the direction? Which yes, the arrowhead. Arrowhead represent the direction. You know, these 2 vectors have same direction, but magnitude not equal. Okay, then how to represent a vector? How to represent a vector? A vector represented by a straight line with an arrowhead. The length of the line represent the magnitude of the vector, and the arrowhead represent the direction of the vector. This is the vector OP. we can represent the vectors using English letters, generally capital letters. Suppose this is the vector A. Vector A can represent like this. Draw an arrow above the letter. Draw an arrow above the letter. This is vector A. That is vector OP equal to, OP is the vector OP is equal to vector A. You can also write like vector A, just write a line. It's difficult, sometimes it's difficult to draw the arrows or in all the vectors. So we write like this also. Okay, the vector is denoted by like this. Then what is the magnitude of the vector A? The magnitude of the vector A is represented by like this. It is called modulus of vector A. What is this? It's the magnitude. Magnitude of the vector. Magnitude of the vector A. Magnitude of vector A represented as modulus of vector A. Read as modulus of vector A. Modulus of vector A. Okay. Now we will discuss about different type of vectors. There are a number of vectors out there. We will discuss detail. First one, equal vectors. Equal means same. You know, vector has both the magnitude and direction. Then when two vectors become equal, both the magnitude and direction become equal. Direction equal means in the same direction. Magnitude equal means they have same magnitude. In graphical representation they have same length. Suppose I draw two vectors, vector A, another vector B. Okay. Yes, these two vectors are in the same direction. Both have same length. Same length means same magnitude. Then A and B are equal vectors. Vector A equal to vector B. We can write vector A equal to vector B. These are equal vectors. Then when two vectors become equal, it has both the same magnitude and same direction. Two vectors are said to be equal if they have same magnitude and same direction. Next one, opposite vectors. What is opposite vectors? Yes, opposite vectors means they have same magnitude. Here vector A, vector B, both have same magnitude, same length, but the direction, what's the direction of A? Yes, towards right. What's the direction of B? Towards left. Opposite. They are called opposite vectors. Then when two vectors are said to be opposite vectors, if they have same magnitude and opposite direction, they are called opposite vectors, also called negative vectors. Also called negative vectors. Negative. Note the name. Negative vectors means opposite vectors, equal magnitude and opposite direction. That is vector A equal to minus of vector B. We can write vector A equal to minus of vector B. Next one, like vectors. Equal vectors of same magnitude and same direction. But like vectors, when we consider like vectors, yes, this vector A, this vector B, these two vectors are like vectors. Then what is like vectors? They have same direction. Magnitude is not important. In like vectors, direction is important. Same direction. Magnitude may or may not equal. Then all equal vectors are like vectors, but all like vectors are not equal. Why? The magnitude may or may not be equal. These are like vectors. Then unlike vectors, you can describe unlike vectors. Vector A, vector B are unlike vectors. Yes, they have opposite direction. Magnitude may or may not equal. May be equal or may not equal. Then all opposite vectors are unlike vectors. But all unlike vectors are not opposite vectors. Okay. Next, we will discuss coplanar vectors. Coplanar vectors. Co means same. Co means same. Planar means in a plane. In a plane. Then what is coplanar vectors? Yes, vectors lying in the same plane are called coplanar vectors. Vectors lying in the same plane. For example, I will draw some vectors, vector A, vector B, vector C. These all vectors are lying in the same plane, same board. These are coplanar vectors. The vectors which are lying in the same plane are called coplanar vectors. Next, collinear vectors. Collinear vectors. Co means same. Linear means what is linear? In a line. Then collinear vectors means vectors lying in the same straight line. Vectors lying in the same straight line are called collinear vectors. Collinear vectors are vectors which are lying in the same line. Okay. Next, parallel vectors. Parallel vectors. Parallel vectors means parallel vectors. Vector A, vector B are parallel, that is theta equal to 0. They are in the same direction. Both are in the same direction. The angle between A and B equal to 0. Such type of vectors are called parallel vectors. Then what is anti-parallel vectors? They are in opposite direction. Vector A, vector B, opposite direction, that is theta equal to 180 degree. If two vectors are in opposite direction, they are called anti-parallel. If two vectors are in the same direction, they are called parallel. Okay. Next one, co-initial vectors. Co-initial. Initial means initial point or origin. That means the tail of the vector. We will draw some vectors. Vector A, vector B, vector C. You note all vectors have same origin, same tail. Such vectors are called co-initial vectors. Co-initial vectors. In the next chapter, you will discuss about force. A number of forces are acting in a point or away from a point, like that, which are represented by co-initial vectors. Co-terminal vectors, this also like that. Co-terminals means what do you mean terminal? Terminal end. That is, end means Yes. Head of the vectors are the same point. Vector A, vector B, vector C. Here, head of the vectors are acting in the same point. They are called coterminal vectors. Coterminal vectors. Next one, an important vector called a null vector. Null vector or zero vector is a vector which has zero magnitude. Which has zero magnitude. Then what is the importance of this vector? Zero vector is represented as zero vector. Zero, write 0 and draw an arrow above 0. It is called a zero vector. It has magnitude 0. Magnitude 0. Magnitude 0. So it is called a null vector or zero vector. Null means empty. Null vector. What is the importance of this vector? It has zero magnitude and an arbitrary direction. We call arbitrary direction any direction. Suppose you are going to one place and return to home, same place, your displacement is 0. Displacement is which type of quantity? It's a vector quantity. Then we will denote displacement as zero vector. Displacement is zero vector. Okay. Another example, if your average velocity is 0, you discussed in the last chapter many cases average velocity becomes 0. If the body moves and return to same position, its average velocity becomes 0. Like that, then the velocity is represented by zero vector. This is the importance of zero vector. Also, we note these points. Some properties of, very simple, some properties of zero vector. Like 0. First property, a vector plus zero vector is to what? Equal to that vector. A vector A plus zero vector equal to vector A. Second property, vector A minus zero vector equal to vector A. If we add or subtract zero vector from a vector, we got the same vector. And the third property, a number into zero vector is equal to zero vector. A number into zero vector equal to zero vector. Note these properties of zero vector. Okay. Just note these properties. We will discuss 11 type of vectors. Also discuss one more. Next, another type of vector, unit vector. What do you mean by unit? Unit means 1. Magnitude 1. 1 means magnitude 1. If a vector has unit magnitude or magnitude equal to 1, such vectors are called unit vectors. For example, if A is a displacement vector, A is equal to 5 centimeter, then the unit vector of A is represented like this. It is divided into 5 parts, that is 1 centimeter, and the same direction. It's called a unit vector A. Okay. Then what is unit vector? Unit vector of a given vector. Unit vector of a given vector is a vector of unit magnitude and the same direction of vector. It has unit magnitude. Unit vector is represented like this. Write A and put a cap. Yeah. It's read as a cap. Read as a cap or a hat. Cap or hat or a carrot. Generally we call a cap. It's read as a cap. Another vector B. What is the unit vector of B? B cap. Another vector a P. Unit vector of P is represented as P cap. P cap. Okay, like that. Then what is a unit vector? A vector with a unit magnitude and the same direction of the given vector. Unit vector is defined for a given vector. Unit vector of a given vector is a vector with a magnitude unity or 1 and the direction of same direction of the given vector. We will discuss one important unit vector. You know the coordinates x-axis, y-axis, z-axis. What is the they are mutually perpendicular. X-axis and y-axis are perpendicular. The angle between x and y, what is the angle? 90 degree. Same, y and z make 90 degree, x and z make 90 degree. Okay. To represent the direction of x, we use a unit vector called I cap. I cap. Then what is I cap? I cap is a unit vector which represent the direction of x-axis. What is the magnitude of I cap? Magnitude of I cap equal to 1 because it is a unit vector, but it gives the direction of x direction. That's the importance of unit vectors. Unit vector along y-axis is represented as j cap. J cap is another unit vector. It has magnitude 1 and it represents the y direction. Another unit vector k cap. K cap. It is along the z direction. Then k cap. We simply call I j k. I cap, k cap, j cap. But we can simply call ijk. Ijk represent the unit vectors along x, y, z axis respectively. Okay. What is the modulus of I cap? Modulus of I cap equal to modulus of j cap equal to modulus of k cap equal to 1. All the three vectors have magnitude 1. They represent the direction of x-axis, y-axis and z-axis. Since they are mutually perpendicular, they are called orthogonal unit vectors. Orthogonal means perpendicular, mutually perpendicular. So they are called mutually perpendicular vectors. So they are called orthogonal unit vectors. Okay, we studied different types of vectors. Equal vectors, opposite vectors, like vectors, unlike vectors, parallel vectors, anti-parallel vectors, very important, unit vector and null vector and coplanar vectors, collinear vectors, etc. Okay. Now we have to discuss the addition and subtraction of vectors. How we add vectors, how we add, subtract one vector from another vector. We can discuss all about this. Okay. Now, first we have to discuss the addition of vectors. Addition of vectors. You know the addition of scalars. Suppose we want to add two numbers. 5 plus 2 equal to 7. 5 plus 2 always equal to 7. There is no another result. Okay. Also for scalars, suppose this 5 is 5 kilogram rice and the 2 is 2 kilogram rice. then we can add 5 kilogram rice plus 2 kilogram rice equal to 7 kilogram rice. Because mass is a scalar, we can add scalars like numbers. Just add the numerical value 5 plus 2, we get 7, and put the same unit kilogram, we get the answer 5 kilogram. But instead of this kilogram, we use 5 meter displacement and 2 meter displacement. We add 5 meter displacement and 2 meter displacement. You know, displacement is a vector quantity. Then the answer is, what is the answer? 7 meter. Sometimes it becomes 7 meter, sometimes less than 7 meter, different values. That is the difference between ordinary algebra and vector algebra. Okay. We use another method. For example, if we are moving 5 meter towards east, this is the direction of east. You know the direction: east, west, north, south. Okay, just remember the directions. 5 meter east, then again 2 meter east, 2 meter east, then the total displacement 5 plus 2 equal to 7 meter. But we take another case. If first he travel 5 meter towards east and turn left and move 2 meter towards north, then what is the displacement? Is it 7 meter? No, the displacement is, you know what is the displacement? It is the shortest distance between initial and final position. This is the displacement. This is not 7, isn't it? Yes. Then how we calculate this? So we must study the addition and subtraction, multiplication, etc., which is called a vector algebra. We must study vector algebra to operate vectors. First of all, we have to study the addition of vectors. How to add two vectors? So we have two methods to add two vectors. Because vector have both magnitude and direction, we must add direction and magnitude. In scalars or numerical value, we just add magnitude, no direction. But in vectors, we have both magnitude and direction. If two vectors are given, we must add both magnitude and directions of these two vectors. So, we must use a new method called vector algebra. This is pure mathematics. Okay. Yes. To add two vectors, we have two methods. First method is graphical method, and the second method is analytical method. What are the two methods to add vectors? Graphical method and analytical method. We have to discuss detail in two methods. Okay, what is graphical method? First we have to discuss graphical method. What is graphical? Pictorial. Using diagrams or picture, we have to add two or more vectors. It's called graphical method. We know how to represent a vector by draw a straight line with an arrowhead which represents the vector. The magnitude is represented by the length of the line, and the arrowhead represents the direction of the vector. Okay, using this vector diagram, we can calculate the result, how to add, how to subtract, like that. It's called graphical method. Graphical method, we have three methods to add two vectors. First one triangular method, second one parallelogram method, and the third one polygon method, which are called triangle law. We have deduced a law called triangle law, parallelogram law, and polygon law. We have to discuss each and every one very detailed. Okay. First method, triangle law of vectors. How to add two vectors using triangle law? What is triangle? Yes, it is a geometrical geometry with three sides. Three sides are represent three vectors. That is the difference. Okay, the triangle of vectors. If we are given two vectors, suppose one vector is P and the second vector is Q. To add P and Q, draw P, I redraw P without change magnitude and direction. We just measure the length equal and same direction. This is P, okay, vector P. What is this called? This is head, this is tail. We are using here head to tail. Head to tail connection. Note this point, the head to tail. The second vector placed here, how we place? The tail of the second vector is connected to head of the first vector. Tail of the second vector Q is connected to first of the head of the first vector. That is like this. Measure the length Q, same direction. These are parallel, same direction. That is, this is Q. Then the resultant is the third side of the triangle. Third side represent the resultant. What is the direction? This is an anti-clockwise direction. Then the resultant is clockwise direction. That is, if two vectors are represented by two sides of a triangle taken in the same order, then the third side of the triangle taken in the opposite order represent the resultant in magnitude and direction. That is triangle of vector addition. How to state? If two vectors are represented in magnitude and direction by two sides of a triangle taken in the same order, then the third side of the triangle taken opposite order represent the resultant in magnitude and direction. This is same order, this is opposite order. If it is anti-clockwise, then the resultant is clockwise. Okay. The length of this line represent the magnitude of the resultant. R is equal to P plus Q. This side represent R means result is called resultant. This is a vector R. Vector R is called a resultant. Resultant means in addition we get 5 plus 5 equal to 10. 10 is a result. In vector form it is called a resultant R, represented by the letter R, vector R. That is R equal to P plus Q. This length represent, we measure the length, we got the magnitude of the resultant, and this gives the direction. How we measure the direction? We measure the angle. Suppose this is alpha, then this resultant make an angle alpha with P. It is the resultant, is the direction of the resultant. Okay. This is the method how to add two vectors using triangle law. One example, we have two displacement. In the first case, can take the first case, we have one displacement, suppose D1. Suppose first we taken D1 equal to 5 meter and D2 equal to second displacement 2 meter. Second vector towards north, 2 meter. Okay. Just D2. We draw the vector D1 with a suitable scale and d2 with a suitable scale in the direction of that vectors. Then draw the third side d1, d2, okay, d1, d2, two sides of a triangle. Then the third side taken in opposite order, gives r equal to d1 plus d2. That is the resultant. Measure this length, we get the resultant displacement, and measure this angle, we get the direction of the resultant. Okay. This method is used to add two vector quantities like displacement, velocity, force, acceleration, etc. We can add using this method. This is the triangle of vectors. Okay, clear? Yes. Yes, we studied one method to add two vectors called a triangle of state. If two vectors are represented, very important statement, please by heart. If two vectors are represented in magnitude and direction by two sides of a triangle taken in the same order, then the third side of the triangle taken in the opposite order represent the resultant in magnitude and direction. That is triangle of vectors. Next, parallelogram law of vectors. It is another form of triangle law. Both are same. I will show that. Okay. Parallelogram, you know parallelogram. What is a parallelogram? Yes, parallelogram means two sides are parallel. Two sides are parallel and equal. This also parallelogram. Square also parallelogram. Rectangle also parallelogram. Two sides must be equal and opposite. Parallel sides. That's the condition. Okay. If we are given two vectors, vector P and vector Q, which are acting at a point, then we can find the resultant using a parallelogram. Draw the parallelogram P. Draw parallel to P. We get the third side. This is Q. Draw parallel to Q, which we get, yes, we got fourth side. Completed the parallelogram. Then we draw the diagonal passing through the meeting point, which represent the resultant R equal to P plus Q. That is parallelogram law of vectors. Statement: if two vectors acting at a point, important, acting at a point. If two vectors acting at a point are represent two adjacent side of a parallelogram, then the diagonal passing through that point represent the resultant in magnitude and direction. This is called a parallelogram law of vectors. So what is the statement? If two vectors acting at a point, very very important statement, you must by heart. If two vectors, once again, please say, if two vectors acting at a point are represented two adjacent side of a parallelogram, then the diagonal passing through that point represent the resultant in magnitude and direction. The length gives the magnitude and making an angle alpha. Suppose alpha is the angle between P and the resultant, then the alpha is the direction. Also we can take angle between Q and R. Suppose it is equal to beta. We can take any angle as to represent the direction alpha or beta. Okay. For simplicity we use always angle between horizontal and the vector resultant. So we take alpha. can take a beta also. Triangle O, we know triangle O is a head to tail connection, isn't it? Yes. Tail of the second vector connected to head of the first vector. That is, triangle O is a head to tail method. What is this method? Two vectors are acting at a point means tail to tail connection. Two tails are connected. So, parallelogram law is also called tail to tail method. Tail to tail method. Triangle law is called head to tail method. Both are same. How we can prove? Look here. This is Q. This vector is Q. If this is a vector, it also Q, because these two are parallel and equal. They are equal vectors. So this side also Q. Using triangle law, we just remove this side. Look here, one side, this is P, this is Q, this is head to tail connection, which means triangle law. This is the third side of the triangle in opposite order, which represent the resultant R equal to P plus Q. R is equal to, okay, R is equal to P plus Q. That means both are same. It is only the two different way to add two vectors. Okay, I will give you one example. We have two forces, one F1 and the second force F2. Find the resultant of F1 and F2. Find the resultant force. Bring this F2 like this. Measure the length without changing direction. Put here. This is F2. That is head to tail connection TT. And draw the parallelogram and draw the diagonal. Diagonal represent the resultant force R equal to F1 plus F2. We can add two vectors like vector quantities, displacement, velocity, acceleration, etc. using this parallelogram method. Okay. In this two method, we have only two vectors. If more than two vectors, we use the next method called polygon law of vectors. Polygon law is used when we use polygon law. If more than two vectors are given, then we use polygon law of vectors. If we are given, suppose we are given some vectors like vector P, vector Q, vector ES, vector ES, vector T. How many vectors? 4. Any number of vectors, like suppose n vectors. Then how to add these vectors? If we use triangle law, we must add P and Q and find the resultant, and add the resultant with S, and add the resultant of that with T. Finally we got the resultant. It is difficult because graphical method is a difficult method because we using a scale. Okay, thus we use polygon law. In polygon law, we draw each and every vector and connect head to tail method like a triangle law. That is, first I draw the vector P. This vector P, I redraw and connect head to tail method Q. Is it q? You must measure the length and check the direction of q. Is it same? Okay, then equal vector. Next, connect any vector can connect. Not an order. We can connect first q, then t, then p. Anyway, okay. Next we add s. Yes, I add the vector s. Okay, the direction just slide. Okay, this is the direction, isn't it? Yes. Is it okay? Yes. Next, t. Measure this length and draw like this vector t. All the vectors are connected in head to tail method. Then the resultant is connect the tail of the first vector to head of the last vector. Connect the tail of the first vector to head of the last vector, which represent the resultant of all these vectors. That is r is equal to p plus q plus s plus t. Okay. In one step we got the answer. We can add any number of vectors using this method. This is the polygon law. We can add any number of vectors using the polygon law. In polygon law, the method is head to tail method. The only tail to tail method is parallelogram law. Okay, understand.